I'm James Schrader, and I'm a research staff member in the Department of Horticulture here at Iowa State University. Along with my other research and teaching activities here in the department, I'm also co-principal investigator on a new $2 million research and extension project titled Bioplastic Container Cropping Systems, Green Technology for the Green Industry. It's a multidisciplinary and multi-institutional project led by Project Director William Graves, who is also in the Department of Horticulture here at Iowa State. As many of you know, the highest standards for productivity, profitability, and efficiency in the container crops industry are achieved by the use of petroleum-based plastic containers. They're light, they're durable, and they're waterproof, so they provide a high water use efficiency during plant production. But there are also problems with petroleum-based plastics. Petroleum costs continue to rise. Petroleum plastics are not biodegradable. The recycling infrastructure is not capable of handling the huge amounts of plastics left over after plant production, and producers can't afford the time or cost that it would take to clean and reuse petroleum plastic containers. The problems with sustainability will just continue to get worse as petroleum supplies decrease and costs increase. Our project will develop and evaluate numerous types of bioplastics for the use in containers that will fulfill all of the functions of petroleum-based plastics without any of the drawbacks. We'll also be evaluating the economic, social, and environmental impacts of bioplastic container cropping systems, and we'll be introducing the technology to the plastics industry, the container crops industry, and educating consumers across the country about the new technology. I have some examples of bioplastic containers that we have evaluated in the preliminary work leading up to this project. This is one of the first prototypes of a bioplastic made from zein protein. It's a protein extracted from corn. Here's a composite container made from zein plastic and cellulose fibers. The cellulose fibers add strength to the container and make them lighter. Here's another composite made from zein plastic and coconut coir. This is made from soy protein extracted from soybean. We'll be evaluating these bioplastic materials that are biodegradable and biorenewable, and numerous others made from materials like cellulose plastic, lignin, keratin protein from poultry feathers, algae plastics, and natural plant and animal oils, so that we can develop the best bioplastics for the container crops industry that should be sustainable far into the future. Our ultimate goal is to develop bioplastic containers that will act just like petroleum plastic containers during plant production and sale, but then can be broken down, installed with the plant in the landscape, and provide fertilizer for the growing plant as the bioplastic biodegrades.